This clip reviews how to solve linear systems by using substitution. The problem asks to solve the system 5x plus 2y equals 7 and negative 3x plus y equals 9 by substitution. The problem in the blue box is for you to complete as we go through the solution for the given problem. When we're asked to solve a system of equations, what we're really looking for is the point of intersection of those two lines. So we're going to look for an x value and a y value. So we're going to start the solution off by rewriting the equations. So I have 5x plus 2y is equal to 7 and negative 3x plus y is equal to 9. I'm going to label each equation. I'm going to number 1 and 2. We number the equations so as we go through our solutions we know which equation we're referring to during each step. I'm going to do the solution in 4 steps. Step number 1 is to use either equation and solve for one variable in terms of the other. I'm going to choose equation 2 because we can solve for y in one simple step. So I'm going to rewrite equation 2, which is negative 3x plus y is equal to 9. And I can take this equation and simply bring the negative 3x to the other side, and I have y by itself. So I get 9 plus 3x. And I'm going to label this equation 3. Okay, so generally we look out of these two given equations which one doesn't have a coefficient in front of a variable. And when it doesn't have a coefficient, then we know we can rearrange it in one simple step for that particular variable. Okay, so I'd like you to try step 1 for your problem. The answer for your problem is shown in the blue box. I'm now going to move on to step 2, and we're going to sub equation 3 into equation 1. We do this so that we get one equation with one variable, and then we can just solve for it. So we have equation 1, which is 5x plus 2y, but we know that y is equal to 9 plus 3x, so we're going to sub that in for y. So we write 9 plus 3x, because this is my y value. That's why I changed it and showed it in red. And that is equal to 7. Okay, so we're going to expand out the bracket. So I get 5x plus 18 plus 6x is equal to 7. So I now only have one variable. I'm going to collect like terms and solve for x. So I'm going to get 11x. I'm going to bring the 18 to the other side. So I have 7 minus 18 is negative 11. Now solving for x, I get x is equal to negative 1. So I've now found the x coordinate of the point of intersection, and then I'll have to find the y. So before we move on to step 3, I'd like you to try step 2 for your problem. Step 3 is to find the value of y. So in order to do that, I'm going to sub x equaling negative 1 into either of the original equations, and I'm actually going to sub it into equation 3 because it's already isolated for y. So we have y is equal to 9 plus 3 times negative 1. So that equals 9 minus 3, which is equal to 6. So I've now found my y value. So now I'd like you to try step 3 for your problem. Your answer is shown in the blue box. Now I'm going to move on to the final step, which is step 4, and we're going to check x equaling negative 1 and y equaling 6 in both original equations. So we're going to do a left side, right side check. So we have equation 1, which is 5x plus 2y is equal 7. So the left side is 5x plus 2y, so it's just the left side of the equal sign. I'm going to sub in my x value and my y value, so I have 5 times negative 1 plus 2 times 6, and I get negative 5 plus 12, which is equal to 7. My right side, which is just the right side of the equal sign, is 7. Left side equals right side. So what this means is that the point negative 1 and 6 lies on this line, which is good. That's what we want. Let's check equation 2, which is negative 3x plus y is equal to 9. So the left side is negative 3x plus y. We sub in our x and y values, so I get negative 3 times negative 1 plus 6, which is equal to 9. The right side is 9, therefore left side equals right side, which is great. That means the point negative 1, 6 lies on this line as well. Therefore, we can conclude, the final statement we need to conclude, that the solution for that given system of equations is the ordered pair negative 1, 6. So that means that negative 1, 6 is the point of intersection of those two given lines. Okay, I'd like you to do your left side, right side check for your problem. Okay, the solution for your problem is shown again in the blue box. So it's important to note that this system of equations can also be solved using elimination, which we are going to show in the next clip.